these functions in Desmos, the big thing they're looking for is those horizontal and vertical asymptotes. So an asymptote is when a function gets really, really close to some value but never quite reaches it. So like in this example I'm drawing here, whatever this function is, it's getting really, really close to x equals 4, that imaginary line I just drew, but it never reaches it. So we call x equals 4 the equation of the asymptote. Okay? You can have horizontal asymptotes too. See how my graph gets really, really close to y equals 0, but it never reaches it. So y equals 0 is the horizontal asymptote. Okay, so we want to be looking for those things. So you can get that by using a program like Desmos online, just typing this in a graphing calculator. But the analytical way of doing it for vertical asymptotes are when you have divide by 0 errors. So you want to think about the function and what it would take for x to cause a divide by 0 error. In other words, take the bottom of the function, set it equal to 0, and then solve that equation. So add 3 to both sides, divide both sides by -2, so 3 over -2, or in other words, -3 over 2. That's the vertical asymptote. So, oh, I can't click because I'm not in Desmos, but what you'd want to do is click this vertical line tool and then go over to -3/2, which is -1.5, and make a vertical line right there. Okay, so that's the trick for vertical asymptotes. Now, horizontal asymptotes follow 3 rules. First rule, if the power is bigger in the top, there's no horizontal asymptote. Power is bigger in the bottom. The horizontal asymptote is always y equals 0. Okay? If the powers match, it's a ratio of the leading coefficients, which means those numbers attached to the highest power. So if you look at those 3 conditions, the power, what we mean by the power in a function means the power of x. Okay, so we get fx equals -3 over -2x minus 3. Now the power of x on the top is 0. It's x to the 0. Okay, you can put an imaginary x to the 0 because that's just 1. That doesn't change anything. The power of x on the bottom is 1. So the power is bigger in the bottom. So that means y equals 0 is going to be our horizontal asymptote. So you draw a line going straight across this way. Okay, and I think it's cut off here, but they want you to plot a couple points for this graph. So to plot those points, let's see, they want it on either side of the asymptote, I'm pretty sure. So we got x equals -3/2. So try to find a point to the left, like this is -1.5, so I'm going to plug in, I don't know if they want 2 or 3 points. I'd have to go back in Alex, but I just haven't got a picture here. But if you plug in -2 in for x, see what it spits out for y, and you use the pencil tool to mark where that's going to be, okay? So actually, let me see if I can think of something better today, because that won't come out to an integer. Think of this. Oh, that's great. Actually, that's a good one to plug in. So if you plug in -2, -2 for x, you got -3 on top still. -2 times -2 makes 4. So that gives us -3 over 1. So that gives us a nice -3. You just plot -3 with the pencil. You go to -2 on the x, -3 on the y. Use your pencil tool there. I think they do need another point. So you want to cross in an integer somewhere where it crosses perfectly. Let me see what else we could do. If you plug in just the next one to the left, if you plug in -3 in for x, that's something to the left of this. Do the same thing. Plug it in for x and see what it spits out for y, but I'll skip that this time because I showed those steps over there. -2 times -3 makes +6. 6 minus 3 makes 3. -3 divided by 3 gives us -1. So use your pencil tool, go to -3, -1, put a dot. And then you've also got to do 2 points. Oh, sorry. After you make those 2 points, 2 points that I just showed, connect them with this tool here, okay? And then for 2 points to the right, plug in like -1 would probably be a good one, okay? Because I'm looking at -1.5. Something slightly to the right of -1.5 would be -1. If you plug in -1, -2 times -1 makes 2. 2 minus 3 makes -1. -3 divided by -1 makes a +3. And then if you plug in -2, whoops, that's not to the right, sorry. Let's plug in 0 for x. -2 times 0 is 0. 0 minus 3 is -3. -3 divided by -3 gives us +1. So -1 on the x, 3 on the y. Use that pencil tool to put a dot there. 0 on the x, 1 on the y. Use that pencil tool to put a dot, and then you can connect it with that tool. So that's how you can graph a rational function. Okay, make the asymptotes first. Then make 2 dots to the left of the vertical asymptote. Connect them with this tool. Then make 2 dots to the right, like I showed with plugging in points.